setup. All right. So whenever I give a talk, I like to try and frame why we're doing this, or what it is that the point of what we're talking about. If you could have 1 million humans go through your app or your site and figure out because what are we trying to do? We're trying to make sure that humans can interact with the computer properly. And who better to do that than other humans trying to interact with it? So like if you could have 1 million humans to do all of that, you're probably going to get the most useful information is going to come from that. But that isn't practical. It doesn't scale. It's too expensive. It takes too long. And so what is it that we're trying to do to solve that problem with a computer? And I think a lot of us, as we're moving from a manual testing mindset to an automated testing mindset, is we kind of miss some of the key differences here, because computers aren't good at the same thing that humans are good at. And you have to make allowances for that. And you have to figure out, how do I get more value from the computer instead of just treating it like a faster human, right? Because that's the first pitch. Like, oh, well, we'll just take everything that the human's doing, we'll write it in computerese and have the computer do it. And then that will just make that computer work nights and weekends. And we all win. And that's not really giving you the same, anywhere near the level of confidence that you actually need, right? The whole point of testing is to be confident that what you're putting in front of the user is going to be a good experience for the user, is going to allow the user to do what they need to do. And so if what we're doing doesn't result in more confidence for the same or fewer resources, then we're taking the wrong approach. So we absolutely need to figure out, how do we leverage what a computer is good at to get the same amount of confidence that we could get when we had a slow manual approach to investigating everything about the app and the browser constantly. So one of the big things here is computers are really good at executing multiple things at the same time, running in parallel, especially for things like, in this where we get, unlike servers or some other things, testing specifically ends up being network as the bottleneck. And so it's a lot easier to do a bunch of different processing things at the same time and have the network be the bottleneck, as opposed to some other types of compute. The goal then, in order to scale things up with automation, is, instead of having these big long flows, like as a human, you're going to sit down, you're going to like, how do I test this, right? You're not just going to go to a random page and do a random thing and say, aha, this is working or it's not working, right? You're going to have a very systematic thing. You're going to go through a long flow. You're going to try and take all of the paths you can in the most efficient way possible to get all of the information in one go. But that's not the way that the computer doesn't need that kind of frame of reference. The computer can literally go to that specific page, do the specific action. Is it working as you intended? So the idea is, instead of these longer journeys that a human would traditionally take, to try and focus them in. And so we call the 3 components of scaling testing for me are atomic, autonomous, and declarative. And the first one is, try to focus on one thing at a time. I'll show this in a second. Autonomous, you want to be able to have repeatable results. And that means you have to have a known state, and you have to have a test setup that executes the same way every time, so that you can rely that the answer is giving you the information that you need from it. And that means this is an issue with test data a lot of the times. How do you make sure that one piece of data didn't cause a problem with another piece of data when they're both being used in the same system? Your tests need to be able to run in isolation, in any order, and at the same time as any other test. And the final thing is declarative. And this is one I've been talking about for quite a while, as far as it doesn't matter how difficult something is to create a test or something. It's not the creation of the project that's the important piece. It's maintaining it. It's keeping up with the changes and the problems, and coming up with the solutions. And so finding the fastest, easiest way to create something is rarely the issue. It really needs to be maintainable. And so it doesn't do any good to create this really great framework that's super parallelized if, as soon as anything changes, everything breaks and you're constantly having to go through and fight it. All right. So Let's start with atomic testing. All tests have three components: an arrange, an act, and an assert. And this is kind of the Gherkin given when then setup. But each test should be focused on a specific action. Like, what is it that we're trying to evaluate? In order to get that, you need some kind of known state to be set at the beginning for the action to take, and then assert based on that. And so, like, I had this Heroku screwed me out of the site recently. I need to go and redeploy this at some point. But got this web app. It's just an address book. I did it. There's two things I'm really interested in when I'm talking about demoing tests. I care about authentication and CRUD, because if you can't maintain state for CRUD evaluations, and you're not going to be able to get all of the testing utility from something. So you've got this journey, right? This is just a user signing in and adding and deleting, creating, editing address book entries, right? I know it's an old school concept, right, in the day of social media, but here's a pattern of maybe the journey that you would walk through. And I put it in code. It looks like that. So what happens if somewhere here around line 167 here, what if that fails? What does it tell us when we run a test? The computer's running this test, it does all of these things. And and this is just like a couple of minute test, or not even that. It's like a 1 minute test, I think. I've seen tests that are literally half an hour, 45 minutes, hour long. We see them, we know that they're out there. What happens when something fails at a longer period, like at some point down there? You're not going to have any information. You don't know exactly what the problem was. You don't know where that problem originated, and you don't actually have any information about the state of the system after that. So for instance, on this list right here, right, like we have to sign in, and then all of the tests after the sign in are going to fail if the sign in is broken. If there was a way to separate that out, and so now you have a sign up, a sign out, a sign in. These are the actions that we care about. So rather than trying to run one test that does all of these things, if we can find a way to split that long running test up into a bunch of short focused tests that each is responsible for one thing, we're going to get a lot more information with a lot less human interaction when we get the results back. So we get the results back, there's like one error and then two failures, and you can see exactly what the problems are and get a better idea faster of the solution, rather than, yes, our test failed, and somewhere in here, like around the 20-minute mark, and you go in and figure out what might be going on there. Oh, it was just a synchronization issue. Let's just retry the whole thing. You want focused, specific information that gives you useful things to optimize for the time it takes you to review it, more so than the time it takes to run it. I think that's the big thing. A lot of people are focused like, how fast can I get this to run? It's like it's not just the execution, it's the execution and the analysis, right? And so if you don't have a really high pass rate, the execution time doesn't matter nearly as much as how long it's going to take you to analyze all the results. And if the way that you've got your results set to return to you is really complex, it's still going to take a lot of time to process the results at the end. So the autonomous piece, so I said atomic, autonomous, and declarative. The autonomous piece comes from test data management, and this is what the last office hours I did was covering. It was talking about different ways to work with test data, and how to make sure things are more likely to be independent. And I walked through like the 4 different ways that you could do test data management. And the key to me for ensuring the most reliability when running in parallel is you need to make sure that your data is independent from each other as much as possible. And the easiest way to do that is just creating synthetic data just in time. So when each test is responsible for all of its own data at the time that it's executing. So it increases the execution time a little bit, but it makes sure that the evaluation time overall is going to be much less, because you know you're not going to have a conflict with other data. You know that things are independent. And people are concerned obviously about, oh, it's going to take a little longer to do some of the data. And this is where, like, once you start again leveraging the computer to do some of these things, running in parallel, use the data. You can actually use an HTTP client to set state or to do assertions on a lot of these things. so that not everything has to go through the UI. You can still completely test the UI, but use an API interaction with an HTTP client to shortcut some of those things in some of those places. And I gave a talk actually at the Lambda Test conference for talk about transitive testing. And the transitive testing is this idea of how can you mix both UI and API interactions with your application to get better results from your full DOM to database analysis. And that's the piece that you can use to speed things back up once you have properly split things out and run them in parallel. And so, and the final thing I wanted to talk about is this is where it gets complicated, right? Like, it's like, oh, let's talk about strategies for parallelization. And it's like, the problem is that there are just so many different ways that it can be done. There's so many ways that it is being done. And not everyone speaks the same language when we talk about what is happening. And so I wanted to kind of split out. There's three different ways that we run in parallel, sometimes in combination and sometimes not. But like the main one is just running command line, right? So we're talking about we execute something on the command line. This is what the CI tool is kicking off in your build. This is what you'll run locally. If you're using an IDE, this is when you're right-clicking and hitting execute. It generates what the command line is going to be and executes it for you. But there's some command line, and usually this is like a build tool execution, like a Maven, a Gradle, or Bazel. These are the things that are executing your test code. And so the idea is you can run, these can parallelize themselves, or you can run multiple of that command line. So one way to parallelize is to have 10 different command line executions, right? You create 10 different builds in your CI, you run 10 of them, and now you've got a parallel of 10. That's not the most efficient way. But sometimes that's the way that you want to do it. You want to tag things with certain things and run kickoff 10 independently, something along those lines. You also have data parameterization, and this is one that I see a lot, especially in Java, especially in TestNG world, where you're parallelizing across, here's a bunch of different data, run all of my tests with each one of these, right? And so we'll see this with, in Sauce Labs, this ends up being like your platform configuration. I want to run on Windows 10 with Firefox. I want to run on Safari, whatever, with Mac, whatever. And I've got 10 of these configurations. And so my data parameterization is going to run 10 in parallel with each of those combinations, kind of a thing. You also see this WebDriver IO also has this in their capabilities. So there's things you can execute on the command line. There's data parameterization you can set up in addition to what's executed on the command line. And then there's also the test runner itself at either a class level or a method level. It will run things in parallel. So for instance, you could have a test suite that is set to run 5 tests in parallel in the test runner itself. So this is like PyTest or NUnit or XUnit or JUnit. Well, JUnit doesn't. TestNG does. The JUnit uses the Maven Surefire. But the idea is that you can have the test runner itself set a certain amount to run in parallel. You can have that parallelized with data parameterization. So if you set these five things in data parameterization with these 5 and run in parallel with 5 threads, you would essentially have 25 in parallel. And that's like how WebDriver IO works, right? You've got your configurations, you set your max allowed, and then they're multiplied to go through everything. And then if you ran that multiple times, multiple of those on a command line, maybe with different tags or something, then you're parallelizing across with that, right? So like there's 3 different dimensions that I like to refer to. And it really depends on what tool you're using and what your product looks like as far as what is best. And so like at one point I'm like, oh, I've got some ideas for best practices for that. And I'm just like, not really. It really is going to depend on a lot of things. I do think that we tend to overuse data parameterization, but in some use cases, I think it's fine. I think I would turned off a little bit by how test-ng does some things, but the way WebDriver IO, I can see why Christian implemented it the way that he did like that. And I think it's also important to point out the class versus method level. Like there are sometimes by test file, it will break it out and run in parallel. So each, like you've got 5 files, you can only run 5 in parallel at most. But if you've got 5 files and they each have 10 tests, there are some solutions where you can run 50 in parallel because it goes off of the methods, not the classes or the files, as it tends to be depending on your language and framework. So figuring out how you want to, like what platforms you need to run on, what your CI setup is. Things have also gotten a lot different since we've moved away from kind of the more Jenkins approach with build CI tools and builds that you run that will parse and then execute some things. And we've moved somewhat into a more webhook, like with the GitHub Actions kind of mode of things, where when things are done, a hook will kick something off and run a specific subset. And so this is like the configuration as code. You end up putting into the code what things like used to be in Jenkins. We would store most of the interesting stuff was in Jenkins itself, configuration things that was completely in. You pull in the code and then you have all the configuration in Jenkins. And now we're moving to a world where everything that the CI needs to know to execute, almost all of that is in the repository itself. And then you'll have probably some secrets or something like that. But other than that.